And it also got a lot of attention because the governor said he put a bunch of money into it. So we're all very, very interested in this problem now. I haven't seen any of that money.
Checking my mailbox.
I did write my note asking people. Anyway, I said just kind of 1%. So anyway, the 4 R's are, when we look at nutrient management, this is sort of the buzzwords right now: right source, right rate, right time, right place. I don't think that it's necessarily that simple, but this is not a bad framework to start with. So we'll kind of start here. And I'm going to talk a little bit about phosphorus management, and I'm going to talk a little bit about nitrogen management. It's very hard to co-manage those. Okay? In fact, if you look at a wastewater treatment plant, they will treat nitrogen, and the water moves through to a new part of the treatment plant, and then you treat phosphorus. Okay? And that's just hard to do on field, right? Like, you can't take your field, treat the nitrogen, then move the field over here, and then do the phosphorus. So we'll look at some of the things we've been doing here. So when we talk about right source, this is one of the things that one of the caveats for the rest of my talk is, these are just the wastewater treatment plants that flow into Cuba Lake. Okay, this is the total phosphorus and how much comes from each of those wastewater treatment plants. But when you look and see how much of that is actually biologically available, immediately at least, it's a much smaller pie. Okay, and actually the proportions actually change quite a bit as well. And so and this tends to be the dissolved forms mostly. Okay, there's some particular phosphorus that is biologically available, but a lot of what I'm going to talk about is looking at how to manage the dissolved forms of phosphorus. Okay, now then, I put this up because there's our pie with all the treatment plants in it, right? This is the amount coming down from the tributaries flowing into the lake. Okay, and so it's a huge fraction. And the unfortunate thing is that So what we have here is this is the biologically available phosphorus. This is the percent of the land used in agriculture. Again, this is for Cuba Lake. And whether you're looking at the particulate phosphorus or the soluble phosphorus, the more agriculture you have, unfortunately, the more phosphorus loads that we get. And these are the actual measurements. There's the modeling here. So this is a good place to start to try and figure out how to manage the phosphorus at least in the Finger Lakes. Now, of course. Well, anyways, we'll come back to it. So phosphorus, we're going to look at the right place. That's what I've done most of my work on, actually. Okay, and so I spent a lot of time looking at these places where water accumulates in the landscape. Okay, those are the areas you want to avoid, right? And so I have thousands of these pictures. Okay, and I'm not allowed to take any more pictures when my wife is in the car. In fact, she has 2 rules for me: no more pictures of wet spots, and you can't buy the harmonica in the car anymore. So those are the 2 things. So these are really the areas we want to avoid. And most farmers know where these are. I mean, it's usually in swales and stuff. But we do have a lot of farmers that come out and tell me, you know, it's easy when it's all ponded up there to see where it's at. But what if I'm out there and I don't know where like this is a kind of a subtle area here. How do I know that that's going to be there? So we spent a lot of time seeing if we can predict where these spots are going to be. And so this was like a 5-year study. I had like 4 students that ran all over the Finger Lakes, stabbing moisture probes into fields. And this thing, can we use GIS to kind of predict where the wet spots and dry spots are? So these colored areas, this is one watershed that flows into Cuba Lake, and the colored areas are all the ag land. And what's hard to see, and so the yellow areas are dry, and the oranges are a little bit wetter, and there's little tiny blue areas in there that are hard to see. Those are the areas that are going to be the wettest and generate, in fact, they're going to generate 70% of the runoff that comes off this landscape. So let's just zoom into a couple of fields here. And so we did, well, let me go back here. So what we did here, the little blue traces in there, those are the wettest 10% of the land, of the ag land. And so what we found is that not all fields are created equal. So here's, and this is just like a clip, there may be more than one field there, but we clipped out a little ag land there, and then we clipped out another one here just for comparison. And you can see this one here has some of these high runoff risk areas in it, but this could probably be managed with some grass waterways. This one here is going to be more problematic. And so there may be a reason to like start looking at that whole watershed when you start thinking about conservation easements as opposed to farm by farm, because some farms are just unfortunately located in bad areas. Okay, so I put up here the right rate, okay? Because we usually think of the right rate in terms of how many pounds of phosphorus per acre, how many pounds of nitrogen per acre. So, but the DEC came and asked us, because most of the big farmers now use liquid manure, okay? And so if you put liquid manure on there, you actually make everything a lot wetter. And then, then you're really susceptible for the soil saturating up and starting to generate runoff. So we've been doing a little work with the DEC to kind of fine-tune the regulations with respect to how much water is going in the landscape, and then maybe also put that in the context of how far out is the next rainstorm forecast. Okay, so it's a little different take on the right rate concept. Okay, and we've done this a million times, but this is the latest one that one of my students did. Let's just focus on, so this top graph is just showing, here's the cumulative phosphorus that's being added to the Fall Creek watershed actually, okay? And here is the cumulative total dissolved phosphorus that would come out with some, some errors in there, if you just spread it all sort of evenly. And this is, the green line here is the cumulative that comes out if you really targeted the areas that were like least susceptible to generating runoff. Okay, so it, we see this over and over again. This happens to be a model study. But in the Catskills, we did have the opportunity to have a small farm that covered a whole watershed, and the farmer was very progressive already, so it was hard to make improvements. But he agreed to do this for, well, he did whatever his normal practices were for 3 years, and we measured how much phosphorus came out. And then for 5 years after that, he said, okay, I'll target the areas that you're telling me based on those maps you've made, and to put it in the best places. And he gave us his records, and well, first of all, there was a huge improvement. We saw this really, the cumulative phosphorus levels coming out way down. But he was really honest, because sometimes he spread it in exactly the wrong area. And we go and say, why did you do this? He goes, waiting to get to, and I just had to get it out of the barn, so I just put it there, and I know I did. But even though, it wasn't always consistently doing the best thing, you still saw huge improvement. So we have empirical evidence, we have this modeling stuff, and so I think this is a good strategy. It's a short-term strategy, okay? You're never gonna, you're just playing a shell game a little bit, because eventually those dry areas are gonna really load it up with phosphorus, and I don't know, someday you're gonna have a flood, and I don't know what the impact of that is, but at least in the short term, this is something we're suggesting as a way to do this. And I'll just mention, Wisconsin got into this whole thing. Can we tell farmers, again, where and when to spread their manure? And they made these models that take, it's always modeling the hydrology, the soil moisture, and then it also is looking at the weather forecast, and then it looks and says, well, here's the areas that are really bad, these purple areas. The orange areas aren't too good, but then these white areas, you're okay. Okay, and this is a tool you can just go online to look for the Wisconsin Runoff Risk Assessment Forecast, RRA. Anyways, so they started this thing, and again, DC and Pro Dairy came and asked if we could get involved with this. Oh yeah, here it is, RRA. This is just a screenshot I took yesterday. So this is kind of a neat thing. It's a pretty advanced tool. And there are now, Minnesota has one. Here's a screenshot from Minnesota. But there's a whole bunch of Minnesota, Wisconsin, Michigan, Ohio, and now we have one of these as well. But we don't have like a user interface, so it's complicated to use. And so I went to they have a conference about these every year. So this is my first year I went and listened to these people talk about these tools. And the technology is pretty cool, okay? But they all said that the problem is manure management is like, if you're a dairy farm, that's your lowest priority. That is a waste product you have to move out of the barn, right? So the incentive to spend a lot of extra time is not really there. Also, especially in the early versions, sometimes it would say there was going to be a risk of runoff, and then a farmer would not experience any rain, and so there was some skepticism about this whole model. And so people have been trying different ways to kind of show these risks. We've done a little bit of work on our own, just trying to figure out how to do this. This is the Owasco Lake watershed, and these magenta areas are areas where, I know, whenever we did this, we were predicting runoff in the next 3 days. You can kind of zoom in here. And we were doing this on a 10 meter by 10 meter, resolution. And I'll just say, the first time I ever showed this, let's go back one. These areas were shown in red. Okay, and I was showing it to actually a whole room of farmers, so I was showing it to. It was amazing how many people were red-green colorblind. We had chosen exactly the wrong thing. So evidently magenta is okay. And so where we're at now, we're kind of at the same point where all those other people are. Is you have a tool, you have end users, and they hadn't really come together to figure out what they needed up front. And so what we're trying to do before we break this out for the whole state is we're right in the process right now of talking to dairy farmers mostly, and saying, what's the information that you need? Do you want to know this? Do you want to know at every 10 meters of your farm where you're going to have runoff? Or do you want, like, we color whole management units as like, this one's probably not a good idea, that one is a good idea. Or do you want something like this? Or is the weather forecast just as good? Okay? And what I would love, my dream would be to get a bunch of farms to use different tools and see what makes. If the model gets finer and finer, do we really see a change in actual water quality? I'm not sure we're doing better than we would do just by using the weather forecast. But anyways, this is where, so New York, we're rolling this out next year, I think. So we'll get a user interface, and hopefully it's something that people want. But again, we're trying to find out what information is useful before we provide any information. Okay, and then we just look at timing, and then again, this is all manure management. And again, this is a model, so, and also everybody should notice that I got here late because I got lost. So everything I say, you should really question a lot. Okay, so what this student did is we had the farmers telling us what their management for getting rid of the manure was. This was for Fall Creek. So this first one, this is the annual amount of mineral phosphorus, dissolved phosphorus that comes out under the current scenario. And then this is that we put no manure down in the watershed at all. Okay. Again, these are hard to do empirically, but with models we can do anything. Okay. And then each of these is how much phosphorus would come out if you spread all the manure in those months. So all in January, all in February would be worse than the current situation. All in December would be too. Interestingly, if there was a way to get the manure out during the summer, which is hard because the corn is up, right? It actually is lower than if you put no manure on. I think it's just because the plants take up all the phosphorus. So interesting result. But it just also shows that right time idea it has merit. Okay, some other things that we're looking at. Yes?
I'm just wondering if that is creating a basis for eliminating winter spreading.
Yes. As long as we still have winter. Maybe we won't have winters here.
So an issue that I see where winter spreading is not allowed is that you put huge loads out there, say in April and October, November. And if you have any kind of a rain event at that time,
your panel goes off, yeah. No, and that's the big, when I get called to go out and see something by the DC, it's usually a winter event, because A, it's really visible on the snow, and B, the streams start foaming in it, and it really is a lot of stuff coming out. But yeah, this does make a case for avoiding. Now, small farmers don't have manure storage, right? So like, when the thing is full, they got to get rid of it. So I have a little sympathy for that, but maybe that's a place where we think about more investment to try and avoid the winter spreading.
How do you explain November?
That's a good question. I don't know. These were, we took 10 years of data. I don't know why November came out so weird. That's a good question. Maybe if we'd used a longer data set, we would have seen more of November. Of course, September and October start to go because this is the hurricane season. We get those big rains coming through. November's after the hurricane season, but it's really low, and I don't know. I don't necessarily know if I advocate November spreading, but yeah, don't look so closely. Okay. But we've been looking at other things too. This was an interesting one. This was a pasture for cows. It was dairy cows when we were there. And the NRCS got some money from the state to put in cattle exclusion, so because there's a stream that runs through here, so to keep the cattle out. Okay, and they want us measure before we do this, so we measure for 2 or 3 years before, and then they put it in, we measure 2 or 3 years after, and this is the total phosphorus that was coming out before, so that kind of gives you the average, and afterwards it was a little lower. Okay, but again, here's where people are important. The guy who owned this, between when they got the money to put the cattle exclusion in, and then they actually put the cattle exclusion in, he retired and rented his land. Okay, and so part of the rental agreement was that the farmer using it had to make sure that this area that the cattle were excluded out of had to stay mowed, okay, because they didn't want to grow in weeds for whatever reason. Okay, so my student's out there making these measurements, and she says, all the cows are like in the excluded area. And I called the not extension, the soil and water conservation district, and said, they're in there and the gate's shut so they can't get out. And they said, no way. We sent them a picture and they go, oh way. And then they went, that's the way the guy was keeping it mowed. Okay? Just let the cows in there once in a while. So even like something that seems like it should be a silver bullet, people get in the way. We're also looking at cover crops a lot. Okay, we've been looking at actually lots of different mixtures of cover crops. Because one thing we found is sometimes when you use just legumes, especially for a prolong, you really build up the nitrogen in the soil. And we actually were seeing leaching events and NO2. So this is that right source thing. I'm all for cover crops. I think they're great. But if you have something that's fixing nitrogen and something that's kind of retaining the nitrogen, if you can get that combination, that seems to be good. And also, we found some combinations were really good at weed suppression. Okay, this is the last thing I'll say about phosphorus. There's a lot we don't understand about phosphorus, how it moves through the environment. And I actually just have a brother-in-law who's a civil engineer and does a lot of work on wastewater treatment. And one of the things that's happened in the last decade or so is, remember I said they move that water through the treatment plant? The last stage, they do what's called enhanced biological phosphate removal. And what they do is they have these organisms that are just naturally in the water. And if they make the water aerobic, those guys will take up more phosphorus than they need and store it in their cells. So this is a picture of a biofilm, and all those things are cells that have extra phosphorus inside their bodies. Okay, and they do that because when it's aerobic, we can amp through more pipes here, they're happy, right? And they're not stressed. So they take up extra phosphorus because they know someday we're going to be stressed and we're going to need that phosphorus to make all the ATP and other things. Okay, so and so we got to look at it. So what this is, they cycle between being anaerobic, okay, and then the last stage they make it aerobic, and these guys take up all the phosphorus and they settle out. And there's places in the landscape that go through anaerobic and aerobic cycles as well. This is a little vernal pool on one of Cornell's farms. And so we want to know, are these things doing anything in the environment? Because they haven't really been studied outside of these treatment plants. So, so one of my students went and got a bunch of rocks out of a stream, and they all had biofilms on them. And then what she did is she's so when it's aerobic, they're going to take up the phosphorus. When it's anaerobic, they're going to release it. So she just sampled the water column. And what she found here is, sure enough, when it was aerobic, that's these white things, the phosphorus from the water column went down because it all went into the organisms. When anaerobic, it went up, and she could keep this going again. And at the end of the cycle, she scraped off the biofilms, and sure enough, these guys were all filled up with polyphosphates. So they're working in the environment. Now we just need to figure out how could they work for us. And so we haven't figured that out yet. But this is sort of like the next thing we're kind of interested in exploring. Okay, I don't know, 5 more minutes?
You've got time. Yeah,
okay.
we're early, so you've
okay.
got plenty of time. And lunch isn't here yet, so.
Okay, good. So let's spend a little time talking about nitrogen. This is something I never wanted to get into. So phosphorus, it sticks around, right? But nitrogen goes off as a gas, and it's really hard to measure because If it goes off as N2, it's really hard to measure because the atmosphere is already 70% nitrogen, so it's hard to tell, did I add any to that? So it's really hard, but I work with one of Dave's colleagues, Lori Drinkwater, and she's big into ecological nutrient management.
Yeah.
Is that what it is? And so she really likes to use these cover crops for fixing nitrogen. And then like I said, if you can grow some kind of grass in there, you can get retention. And it sounds like that's what was being done. For here, right? So that's great. And the interesting thing, I think, about cover crops, 5 years ago, for sure 10 years ago, there were no cover crops in Tompkins County. Now I would say 20% maybe?
Yeah.
Some of it even shows up in the ag statistics, right?
Yeah, I mean, New York is like 36% now. Oh,
Okay.
and the whole
So
state.
the whole state, okay. Which is, I think that's really cool. And a lot of this was done not because there was any mandate. It was just like, we don't want to be blamed or the things we can be doing to try and manage our nutrients. Interesting, I rent 3 fields to a farmer who doesn't cover crop them. And I asked him, because there's a 4th field we also rent, and that one he cover crops every year. And the problem was that these are such tiny little fields, he's just afraid he'll compact the soil just getting in there, because he has to, they're just too small. So there is some limitations that are, mechanistic limitations for cover cropping evidently, but I'm glad I didn't accuse him, I just was asking why.
Well, I think part of the motivation for farmers doing this, besides the nitrogen thing, is just the increased frequency of heavy rain events, and they see erosion control, which gets back to your runoff story.
Right, and erosion, we don't know why necessarily, but we're getting a lot of gullies throughout Cuba and Tompkins counties, and so we're trying to find ways to deal with those. But I think you're absolutely right. And you can see this is one where they, so who was saying their grandfather liked to plow?
It was the farm.
The farm guy, right? Because my grandfather was the same way. When I was a young kid, I remember Grandpa would plow, and he was in Illinois, so it's a square mile, he'd plow. And he'd get out his tractor, if there was any residue on the field, he'd plow the other direction. And he would do that back and forth until there, no residue, now it's clean. And it's, anyway, so I think it's neat that now you see the plunge that was here before. Okay, so this is one, I think this is one of the specific ones you asked about. These wood chip bioreactors, okay? Basically, when you say bioreactor, it sounds high-tech, right? It's a hole into which you dump wood chips, okay, and then cover it up. Okay, that's what a bioreactor is. Okay, so what's done typically in New York, I think out west as well, is you catch the leachate in the tile drain, then you run it through this big hole full of wood chips, okay? And then you usually have some sort of a device on the ends that you can use to control the water in there, okay? And because you want it to stay wet, the wood chips provide carbon, and then the hope is that the nitrate will turn into nitrogen gases and go away. Then the nice thing is when you're all done, there's nothing to see except for a couple of these things that are controlling the water level sticking up. So, and so we put in maybe 20 of these around the state as part of a conservation innovation grant, just to see if they'd work. And we put them on different types of farms, and they actually work better than I thought they would. This is nitrogen reduction for. So we had in every farm we put a pair in. Okay, so we could. So this is the reduction in the concentration, all of them positive reductions, meaning that they went down, and this is the reduction in the loads coming out of those things. And so they seem to work. And these ones have been in for 5 or 6 years now. There's a couple in Ontario that have been in for almost 20 years and still working. The concern we always had was what happens when those wood chips all rot out? Then you got to go dig them up, and that could be a big pain in the neck.
Just put this in perspective with the talk I gave. In that same condition, you could have more nitrous oxide emission.
Okay, that's a good point. That's not a laughing matter. Yeah, that is a concern, and that's one of the things we're measuring right now. Is because the other thing we get a lot of methane out of these too.
Yeah.
Okay, so there's no silver bullet.
Yeah.
Remember back in the 70s, wetlands.
Yeah.
We're going to cure everything. That's the kidney of the watershed. Just put more wetlands in. So there are some drawbacks.
Are you trying those with biochar as well?
Yes.
Is that the BC in that?
BC, yeah.
Okay.
The biochar, the idea with that, remember we said it was hard to do nitrogen and phosphorus at the same time? We were hoping the high surface area of the biochar would sort out phosphorus. We have a colleague in Virginia who says he got it to work. We tried to replicate it and we weren't able to get it to work. I don't know why. So,
In fact, initially it actually produced more.
yeah, our first year, and I don't think it was the biochar, but I think the wood chips, just as they first degrade, that there's phosphorus in organic matter. So yeah, the first year we had a lot of phosphorus that came out of it. Yeah. Thank you again. We don't need to talk about.
There's a lot of detailers here in the crowd.
And so this guy, Will Pluer, was my student working on this. He tried to figure out what makes him work, how can we make him better. And so he did a bunch of lab experiments, and he found, so in this top graph here, he's looking at the inflow concentration, and he saw that the reduction, okay, these are a little weird, the reduction went up the higher the inflow concentration of nitrate was. And also the reduction in the actual load of nitrogen went out. Also, you could get higher reduction if you could increase the time the water stayed inside the reactor. This looks like it's going down just because of those points. There's almost no change in the load out with the residence time. In fact, we find if you do about 6 hours, that's usually I think people are designing for. But there's another big control on this, and we did another study where we looked at these things over ones in the field over time, and I think the only thing we really need to look, well, okay, we can look at this. We look at the nitrate concentration coming out of the reactor. It's low in the summer, starts to go up in the winter, and then it got too cold. This woman was from, I think, Bangladesh. So there was a time where she didn't go outside anymore, okay? And then next year. So anyway, but then you can look at, if you just look at the nitrate reduction, you can see it was almost 100% for these two reactors in the summer, and then the reduction went down in the winter, and you saw this cycle happen over and over again. So, so the other big control on these things, and this is from a woman named Kelly Addett at University of Rhode Island, who took all the studies up to 2017, and she found out that one of the big controls was actually temperature, which is what we're seeing there. If it's warm, you get bottom of the fudge. You know, you get a lot of root removal, and if it's cold, you don't. So they don't work that well in the wintertime. Okay? And so Will got a little crazy about these bioreactors, okay? So there's this woman at Cornell named Rebecca Schneider who's passionate about road ditches, right? It's one of the two things she'll talk about. Yeah. And she said, oh, all this water that comes out of the fields goes into the road ditches. Can we put a bioreactor in the road ditch and treat the nitrogen? So this is a big sock, basically, full of wood chips, okay? And they took it here and they measured the flow rates and the concentrations. And it actually kind of worked, okay? Obviously, when the water gets really deep and goes over, it doesn't work. But it actually kind of worked. And so, this is a little insight to Rebecca's mind. She said, well, this year, I'll put 2 in, okay? And so, I haven't seen those, I think she just told me one time when I was in passing, she said, it did reduce it more, but not twice as much. You start getting diminishing returns. But she's so passionate and so convinced, she should be the one who comes and talks next time, anyway, that the Chesapeake Bay program is now putting these in the road ditches, the rural road ditches in the Chesapeake Bay watershed. Okay, so we had 1 year of data, and Rebecca convinced them this is the answer to all your problems. Okay, and if the Chesapeake Bay gets better, she'll claim all about the wood chips in the road ditches. I can't believe you got permission from the highway department to do that, but anyway. So.
Well, she was probably passionate enough to convince them. Yes!
Do you see these humble moves? Yeah, no, algae above and none below. And so Will got even a little crazier, okay, if you could imagine this. And so he, an engineer in Florida contacted me and said, we got these stormwater retention basins in all our residential areas, and of course all these people fertilize them. Their lawns are well fertilized. And so they get tons of nitrogen in there. And he said, well, I just made this sock for the road ditches. I don't think that'll work here. So what he did is he made a big cage, metal cage, filled it up with wood, he put a perforated pipe in the middle, filled it up with wood chips, then plooped it down into the pond. Then he had pumped the pond water down through this cage of wood chips, so then the water had to go back out through the wood chips. Now this is the remarkable thing. I don't actually believe these results, but this is what he got anyways. So he had 2 ponds, okay, and this first bar, that's the nitrate level before he put his cage of wood chips in there, okay. So pretty high, both these, 8 milligrams per liter, 4 milligrams per liter. And then afterwards, it went down below the detection limit of our machine to measure these things, okay? But he also saw that the chlorophyll A did the same thing, okay? And these are 2 years following when he put these things in, right? So the chlorophyll A is measuring, of course, the algae rate. So the algae actually went down as well for the 2 years after he put these things in. If they're working, okay, which is an if this is real, and it's published, so it has to be real. What he found is, if you look at the dissolved carbon in the lake itself, when he put these things in, there was initially no carbon in the lake, and then it went up. So I think he just made the whole lake into a big bioreactor by just all the carbon coming out of these things, and now we can denitrify everywhere. So that's one explanation for why it might work. It's anyway, the point is, you can take an idea that's pretty good, and just get nuts about it, and that's what we'll do.
So how big a one do you need for each finger?
Yeah, really.
We should call Bill. Okay, he can design
That'd
it.
get really crazy.
The thing is, we work with this engineer down there. So the thing we didn't have here that always has annoyed me is we had 2 other ponds that didn't have the cages of wood chips in them. It would have been nice if he had sampled those so we could compare to a control. So that's always been something. And when he submitted this for publication, that our viewers are going to say you have no control, so we don't really know. But
They accepted it.
they accepted it. So anyway, so those are some of the innovations which we're doing with phosphorus and nitrogen, and those are the people that actually did the work. There's the wood chip sock guy. Any other questions or comments?